This is problem number 29 from section 5.3, in which we evaluate the integral x minus 1 over the square root of x from 1 to 9. There's a couple different ways you can do the problem, but the easiest way is to actually convert this fraction x minus 1 divided by the square root of x into a more familiar format, which is closer to the polynomial format with the exponents. So the first thing you need to do is take the square root of x and just divide the numerator individual parts by square root of x. So here, this is what I did, and then from the next step you can see that x divided by the square root of x simplifies to just the square root of x, and that's x to the 1, x to the 1/2, so 1 minus 1/2 gives you 1/2, x to the 1/2 square root of x. And then 1 over the square root of x obviously stays the same, and then from here you can actually convert this form right here into a polynomial with just exponents without any fractions. So that's going to be x to the 1/2 from x square root of x, and then 1 divided by the square root of x is going to be x to the negative 1/2. And from here you're just going to find the antiderivative directly. So that's going to be 2/3 times x to the 3/2 minus 2 times x to the 1/2. And now that you found the antiderivative here, you can actually plug in the bounds a and b, 1 to 9, directly into the antiderivative here. And this is what I did right here. And then once you work out the calculations and the fractions, you're going to get 40 over 3, which is your final answer. Now this problem is actually from section 5.3, and it's based on the fundamental theorem of calculus, part 2 right here. And it just says if you have an integral of the function of x from a to b, to evaluate it from a to b, you can actually find the antiderivative of capital F, which is what it represents here, plug in the values of b and a, and then you'll find your evaluative value right here. And that's it.